What I'm going to do today is talk to you a little bit about the benthic and fish monitoring program in tributaries and Mainstem. This is a synthesis of all the work that we've done in the first 3 years of JOSM, so I've had to select out certain trends to show you, but hopefully it'll come home. Now, there are many people, as you can see on the list, many organizations that have contributed to this, and I'll just acknowledge them that way. The overall objectives of this program are outlined in the JOSM Phase 2 program. There are ecosystem health questions, basically, what is the current status of the Mainstem fish Benthos? Can we establish a baseline? Can we assess the potential change since historical times? And can we define differences between reference and impact? The cumulative effects questions were related to, is there evidence of cumulative effects in these systems? Development along the Mainstem, for example, and can we define predictive relationships in these? Now, a major part of our program was defining methods, QA, QC, and so forth. I'm not going to talk anything about that, but we do have standard operating protocols now, so that was one of the big advances in this program. The overview of the talk, I'll talk about fish and benthic programs divided up into Mainstem and then tributary study design and so forth. The Deltaic Wetlands, I don't have time to talk about that. I had intended to, but I can't today. But what they have found in the delta and the pad is there's a good ecological condition in that system. They have methods for monitoring those wetlands, and their work now is focused on looking at relationships of the pattern, the biotic pattern, to environmental drivers. At the end, I'll talk a bit about a causal assessment that we are working on. So I'll jump right into the methods for the fish. And this is pretty much the standard approach we took everywhere across these fish and benthic. So there are reference sites that are outside the oil sands deposit. Then there are reference sites within the oil sands deposit with no development. And then there's areas, exposure sites where there's development. And you can see, if I can do this, in Mark's design, so there's references outside the oil sands, inside oil sands, but outside the development, and then inside the development. What they did is at each one of these areas, and this would be, for example, the Mainstem, they then took 20 adults, 20 adults, females and males, and then young year surveys, and they did various indicators, environmental effects monitoring indicators on these over the 3 years at multiple sites. The endpoints for fish are listed here. Survival, and that's they looked at age distribution, growth, size at age, reproduction, condition indices, and I'll report on some of those, and you can see some of the pictures of the ghastly things they do to fish. Invertebrates are much more, you just put them in a jar. Okay, so the site locations for fish. This is both the tributaries and the Mainstem, and maybe if I turn around here I can show you. So in the Mainstem, their upstream sites are at Athabasca. They have one upstream of the sewage and pulp mill and one downstream. And then they have sites that are distributed all the way down through the Mainstem, as well as there are sites along the tributaries, largely the Steep Bank and Muskeg and Firebag, but there are some other sites. But so you can see it was quite an extensive sampling program. In the Mainstem, there were 3 species of fish that they focused on. These are species that have been demonstrated to be easy to catch and so forth in earlier environmental effects programs. And so they looked at small-bodied trout perch, there's a small-bodied fish, walleye, and then their large-bodied white sucker. Their sampling in the Mainstem was done by, you can see the picture there, is a boat electrofisher as well as some seining. Today, I'll just give you some results of the Mainstem for the white suckers, which starts here. This is a complicated diagram, but basically, if you just focus on this top condition factor. White sucker, this shows you 2011, 2012, 2013 at various sites. From the red bar is upstream reference site, and then in 2012 they added another blue bar. That's also upstream in the Athabasca region. And then the other, the purple, yellow, and green are all downstream inside the oil sands deposit and around the development. And the main story here is that if you look at that red horizontal line, that's the average condition of the fish over those 3 years at the reference sites. And then if you look at the difference between the red bar and then the purple, yellow, and green in the 2011, 2012, you can see it's getting into 2 standard deviations away from their mean, meaning that there is a change in condition in those fish downstream. And it really is a signal of nutrient enrichment. There's also, as you'll see, some indication of contamination as well. So the other two, the gonadal somatic index and the liver somatic index, really don't show anything, any trends that we can really make much out of. So the GSI was similar throughout all sites. And then the males downstream of the development showed an inconsistent change in liver size. So then the pattern, I guess, was the same for females. So it's a nutrient signal there. In terms of exposure to contaminants, this EROD is an exposure indicator, and you'll see that if you compare these upstream reference sites to all the sites that are downstream in the deposit, there are significant differences in all years. Again, it's telling us there's some sort of contaminant exposure and a response to that, but it's really not showing up in terms of change in liver size. So it's a mild effect. In terms of the tributary fish sampling, different species there. Longnose dace, these are small minnows, lake chub, and then slimy sculpin. I'll just report on today on the slimy sculpin. And their techniques were basically backpack electrofishing and some seining. And I will point out, yesterday there was a point that are we using past historical data and sites? They were actually integrated with the former ramp sites and sampling at the same time as some of the ramp programs. It's a bit complicated slide, but it shows female slimy sculpin gonad size and reproductive indicator at across a number of years at a number of sites and tributaries. So from 1999, they had some earlier data all the way through 2014. These boxes are the means, plus or minus 2 standard deviations in the first case, plus the previous 2 years. So what they're looking at is, here's our expected range in terms of where values should fall, and then as they move across, they do a weighted average, so they increase the number of years they're including. The first thing I'll point out is that this is steep in the lower part of the steep bank, and this is lower part of the lower sites in the muskeg. The next year, this is the lower site in the steep bank. So what it tells us is there is a change in gonad size. There's smaller in the lower parts of those watersheds. That's in the area that overlaps with industrial development, but it also overlaps with the deposit, increased exposure to the deposit. I'll have to speed up or I'll never finish. Okay, so in that exposure that I was talking about, that change, also you can see they flipped it here so that the 3 bars on the right are the upstream sites, and you can see that there's not much, there are much lower pHs, total pHs in the body tissues of females and males, and much higher, and that goes along with that exposure downstream at the very lower sites. So it's suggesting there's a contaminant signal in those sites at the lower end. Now, in terms of the mainstem benthos, I'll switch to that now. A similar approach in terms of we looked out, so the sites were from upstream Athabasca all the way down to M9, which is just outside the park. So a large number of sites on the mainstem. So the outside the McMurray formation, inside reference, and inside exposure. here what we did was at each one of those sampling reaches, we took 5 replicate samplings, locations along that, so it's quite a rigorous design. And before this program, there was no mainstem sampling at all. The methods we used were simple kick nets, which is we use worldwide. It's a very standard approach. We collected algal biomass. We did other sampling of water and so forth. And I'll just show you a quick, the pattern that we see along the river. And this is a pattern which we've been able to see every year. I've just chosen 2013. So what you see is, oops, back up a step. What you see is the upstream areas where the reference areas are different from the areas downstream. And I should point out each one of these points represents the entire community. So it's a way of representing the community composition. So there's a difference between upstream, the area in the oil sands development area, and then what we tend to see is these downstream sites tend to pop out, and often they curl back towards the reference condition. The reason for that change is we have higher intolerant groups in these upstream sites, and we see more of the higher intolerant, and then we see more tolerant to pollution groups, midges and worms in this downstream area. This is, again, a nutrient. It looks like it's a nutrient signal largely, but there could also be a contaminant signal there as well. In terms of the relation to drivers, I'll just quickly point out that these sites where we see downstream, we see increasing nutrients associated with that, and decreasing vanadium is associated with some of the upstream reference sites. The tributary design shown here, again, it was the idea of outside, inside, and then inside deposit that are impacted by development. There are 4 rivers that they largely worked on. I'm just going to report today on the steep bank. And so there was these reference outside, reference inside, and then there was what we call test sites. The sampling methods, again, were kick nets. We also did a number of other algal biomass samples, water chemistry, and other physical samples as well. In the steep bank, they found that the reference sites outside the deposit were no different in terms of the composition of invertebrates to the reference sites inside the deposit. However, when they look at their test sites, and these are the test sites groups here, 1, 2, and 3, that show increasing lease area, increasing disturbed area. When they compare their reference sites to those 3 groups, what we find is that the test group 1, this one is furthest upstream, further down in the steep bank, you see that the test groups, largely it's a shift in the kind of organisms. It's not a wow, this looks really polluted, but there are certain we can detect changes as we move downstream, and it's again associated with the areas of atmospheric deposition and increased oil sands deposit. Now, I'd like to spend the last little bit trying to make some sense out of all this. Ian Drapoa and I have been putting together these causal pathways, and what I'll do is just quickly show you this one, and then I'll show you the mainstem and the tributaries. So what we have here is that you can see the ecological effects. What we've seen in the mainstem, we see lower intolerant taxa in these areas. Downstream, higher invertebrate biomass and algal abundance. I didn't talk about that, but mussel condition is reduced. Fish health, we see increased white sucker size, and also this EROD activity, which is an indicator of exposure to contaminants. So those are your ecological effects. And then if you look at up top, the sources, municipal discharge in Fort McMurray is one of the major ones. The oil sands industry, there's at least there's 2 phases, the land clearing and then the operations. But then, of course, there's the natural bitumen processes that are occurring. And in the middle, what we have are what we call the candidate proximate causes, so increased nutrients, contaminants, sediments, groundwater. And when we've looked at the pathways. I'm not going to talk about each one of these because this is so complicated, but each one of those arrows, we've looked at the evidence that we can see from all the various JOSM work and evaluated whether it's plausible that could be a cause of these kind of effects we're seeing. And here's the summary then for the Mainstem. So the more plus signs means the more evidence and the more stronger, more confidence we have that that pathway is an important piece. So if you look at from left to right, I guess, left to right, the 3 pluses that come down from municipal discharge, we have evidence that there's higher nutrients coming out of that system. We see invertebrate changes downstream of those sites, increased abundance. And we also see a change in fish size. All of those tell us it's a nutrient signal and all the kind of things expected in terms of a nutrient effect. We also see have some plus signs that coming down from municipal discharge contaminants. We don't think it's all that important. Perhaps land clearing, there's some suggestion of that. And then the next one you see is the operations. There's 2 plus signs there. So there's the areas where we're seeing the effects or the changes, and again, they're not dramatic, but there are changes, is the area of higher atmospheric deposition. We see higher exposure indicators in the fish EROD, and we also see increased contaminants in the fish. And then the final one I will point out is over here in the natural bitumen. We also know that in those areas there's, through the modeling that Ian and his group have done, higher flow and erosion and high flows and higher deposition. So what I point out here is, although we're seeing effects, where we are now is we really cannot at this point distinguish whether some of these 2 effects, the natural versus development side of things in terms of exposure to bitumen. In terms of the tributaries, it's much simpler because we don't have the nutrient enrichment from a municipal source. So there's really only a couple or 4 pathways that look like they're important. This one, which is from the operations, again, we see changes in the area where there's atmospheric deposition. That's confirmed with some fish EROD and higher PACs. We see a change in the benthic invertebrates, particularly a shift in the kinds and abundance of those invertebrates. And then downstream areas are also the areas where naturally you have higher exposure to erosional materials, depositionals, habitats. So again, it's a confounded situation in which we need to and that's the next phase of what we'll be doing is focus studies there. So we'll be doing something like this as well for the Delta in terms of these kind of causal pathways and moving forward. These will all be part of our synthesis report, which should be done by end of March, and all of our technical reports will be released in the coming year. They're out for external review now. So in terms of moving forward, in terms of the program, I think we're going to be looking at periodic adaptation of these monitoring network, incorporate new information and so forth. There's a number of areas it looks like we need to do some very specific focus studies, and those have been proposed. A better understanding of the contaminant sources, the development versus natural. And we need increased sampling in terms of reference sites in some areas, evaluation of endpoints. We need to improve that within sites and among years. And then the fish has a particular strategic plan. And what we did find is that the EEM, the Environmental Effects Monitoring program that's been developed, seems to work well for aspects of this program. So I'll just finish with, there's a large number of groups that have been involved, and they're listed there. I won't go through all of them, and I don't know if I'm over by a few seconds, so I don't know if I can go more, but that's kind of where we are with the synthesis.